Alright, this is Jahangir from MedPorium, and today we have the second half of Part 5. Now, Part 5 will discuss urine and renal function tests. The last video, which was the first half of Part 5, we only talked about urine. Now we have the second half of Part 5, in which we will talk about renal function tests. Now, there are two methods to determine renal clearance and glomerular filtration rate to find kidney disease. Now, today we'll work on renal clearance and glomerular filtration rate. So let's start by renal clearance. Now, renal clearance is how fast the volume of blood plasma from a particular waste are removed in 1 minute. And this is found by collecting samples of blood and urine, including the rate of urine output. To understand renal clearance, let's move over to the ThinkPad. Alright, so we're at the ThinkPad and we want to understand renal clearance. Well, to do that, we need to identify the equation to find renal clearance. And that is stated by C, which is renal clearance, equates to concentration of urine of a particular substance that we're trying to find, times the rate of urine output divided by that plasma concentration of the particular substance. So basically C equals U times V divided by P. So to understand renal clearance, we are going to use urea as our example and find the renal clearance of urea. So for a healthy person, the urea concentration in urine is about 6.0 milligrams per milliliter, and that is our U. Now we multiply that by the rate of urine output, and usually for a healthy person, the rate of urine output is usually 2 milliliters per minute. And now we have our U and V. So we divide that by P, or our urea concentration in the plasma, which is 0.2 milligrams per milliliter. So we multiply 6 times 2 and divide that by 0.2, which would equate to 60 milliliters per minute. And that is the renal concentration of urea for a healthy person. Alright, so we just wrapped up our conversation about renal clearance from the ThinkPad. Now let's talk about glomerular filtration rate. Identifying kidney disease is found through glomerular filtration rate. Now, identifying glomerular filtration rate helps us understand how our kidneys are functioning and what's wrong with them. What can we fix? So glomerular filtration rate cannot be found through substances found in urine because these solutes are always being secreted or reabsorbed, meaning they won't stay in the renal tubule and they won't give us an accurate description of the glomerular filtration rate. In clinical practice, glomerular filtration rate is found through creatinine excretion because creatinine isn't reabsorbed or secreted as much, meaning it stays in the renal tubule most of the time. Also, an injection of the polysaccharide inulin is also used because inulin also stays in the renal tubule. It is neither secreted nor reabsorbed. So with an injection of inulin, glomerular filtration rate would equate to renal clearance, meaning glomerular filtration rate would have the same equation for renal clearance. To understand this, let's move over to the ThinkPad. Alright, so we're at the ThinkPad and we want to understand how inulin injections can make a glomerular filtration rate test more accurate, so it could equate to the renal clearance. So to find glomerular filtration rate with an inulin injection, we're going to replace glomerular filtration rate for renal clearance in the equation. So glomerular filtration rate would equal to the concentration of that substance in the urine times the rate of urine output divided by the plasma concentration of that specific substance. Now, this is the original renal clearance equation, but we substituted that renal clearance for glomerular filtration rate. This is only if there's an inulin injection. So we will use inulin as our example. So there is a 30 milligram per milliliter of inulin concentration in the urine times the rate of urine output, which will always be 2 milliliters per minute for a healthy person on average. Now we divide that by our aniline concentration in the plasma, which is 0.5 milligrams per milliliter. The plasma concentration is also called the drug concentration. Now, as we multiply 30 by 2 and divide that by 0.5, milligram, milliliter will be taken off or excluded, which would equate to a 120 milliliter per minute for our glomerular filtration rate. Now, a 120 milliliter per minute glomerular filtration rate is the usual normal glomerular filtration rate for a healthy person. To summarize glomerular filtration rate, we have these laws. Now, the first one is a solute that is reabsorbed by the renal tubule will have a renal clearance less than the glomerular filtration rate. So to understand this, let's draw ourselves a renal tubule. Let's just say this is our renal tubule. Now, as the law states, a solute that is reabsorbed by the renal tubule will have a renal clearance less than the glomerular filtration rate, and that is due to the fact that they are being reabsorbed. They are moving through the body's tissues. A great example of this is urea. Urea has a 60 milliliter per minute renal clearance, as we talked about before. Now, glomerular filtration rate, we said it was 120 milliliters per minute. And as you can see, 60 milliliters per minute is less than 120 milliliters per minute. Now let's talk about the second law, and that states a solute that is secreted by the renal tubule will have a renal clearance greater than the glomerular filtration rate. So let's use creatinine as our example. So creatinine, let's draw ourselves a peritubular capillary. Creatinine will be secreted from the peritubular capillary and into the renal tubule, and that creates the renal clearance greater than the glomerular filtration rate because it is moving to the renal tubule, making it more concentrated. That's why creatinine has about a 140 milliliter per minute as its renal clearance, and that is larger than the normal glomerular filtration rate, which is 120 milliliters per minute. Alright, so that concludes the second half of part 5. In the second half of part 5, we discussed renal function tests, including renal clearance and glomerular filtration rate, and how these can help us identify kidney disease. And as always, a pomodoro a day will make you a doctor someday. I'll see you next time.